Hello everyone, welcome to Mudgal Education. I hope everybody is doing very well guys and कैसे हो आप लोग? So guys, this is the first video on my channel on the subject signal and system. So we are going to start this particular video. Now before starting a video, I will also go giving you one important information that I have launched my app and the paid course is going to start from 24th April on the app, and the paid course are going to be have three particular courses. Right now I'm going to upload, and the classes will be live class. Okay, you will get the recorded session of that live class, you will get the PDF, you will get the problems also, practice problems, and test series also. So everything is included in that particular package. You can buy my course either at a subject wise, or you can buy the course for the whole gate examination for both electrical and ECE. And all the classes are going to be live right now. For the subject wise course, you can buy network theory and a signal and system. Both of these batches are going to start from 24th April, and the remaining, if you talk about the complete batch, it is also going to start from 24th April. Okay, so the fees is also very minimal. If you talk about the subject wise, the fees is around 2100. If you talk about the full gate syllabus, the fees is around 12.500. So the fees is minimal, but the point is I'm going to provide you the complete knowledge for the gate examination, so that the next year or gate 25 you will score a wonderful rank with a wonderful marks. Okay, for any information you can contact me. The whole information link is given in the description. If you are new to this channel, kindly subscribe it. Also you can join my Telegram channel and ask your doubts there. And don't forget to download the app. The link of the app is also given in the description of this video. Okay, let's start. So guys, as I told you, first of all, let me introduce myself. My name is Ishaan Mudgal. I have a 7+ year of teaching experience. I'm a gold medalist from NIT Allahabad, 8 times gate qualified, and these are my area of expertise. Now, before going further, let me tell you that I have already uploaded few videos on a network theory. I hope you have already watched it and learned something new. Now, in today's class, I'm going to bring one very important topic of a signal and system, and that is energy and the power signals. As you know, the signals has been divided into various classification like periodic, non-periodic, symmetric signal, non-symmetric, even, odd, and much more. One of these classification is the energy and power signals. Now, energy and power signals are very important to identify because the properties like Laplace transform, Fourier transform, and I will say the Z transform are based on these properties. So we are going to understand both of these particular signals, but before that we should understand what is actually the formula of energy and power. Once we understand how to find out energy and power, then yes, you can easily identify which one is an energy signal, power signal, and which is neither energy nor power signal. Okay, let's start. So here you can say, first of all, I will write down the energy of a continuous time signal. The formula is very simple. The formula of energy is very simple. The energy is equal to integration from minus infinity to infinity xt whole square dt. Xt whole square dt. So this is the formula of energy, a very simple energy. What is xt here? Xt is a continuous time signal. Xt is a continuous time signal. Now in different books you will identify that formula is given based on a periodic or a non-periodic signal and much more. So let me tell you, no need to remember each and every formula. This one formula is more than enough to remember it. You will see some formula is given in form of limit also, but that's not required. You just need to remember this formula of energy and that will be more than enough. Now when I write down the mode of xt, why the mode of xt is important here? If you have any real signal, then there is no problem. If you have any real signal, there is no problem. You will have a same signal here. So mode of xt will be equal to the xt when you have a real signal. But when you have a complex signal, so basically the mode of xt will give you the magnitude. The mode of xt will give you the magnitude. So if I tell you about a simple formula of energy, it is minus infinity to infinity xt whole square dt. Okay, now understand one scenario. If I talk about a periodic signal, okay, let's take an example of a periodic signal. Let's take an example for a periodic signal. Now I'm going to take an example of sinusoidal. I'm going to take an example of sinusoidal. Now the sinusoidal is like this. The sinusoidal is like this, and also in a negative half cycle, right? Now if you observe this signal, and let's calculate the energy here through the common sense. I'm not going to use the formula directly here, but just use the common sense to identify how much energy will be available in this signal. So if you observe carefully, in energy formula we are going to integrate from minus infinity to infinity. So if I'm going to integrate from minus infinity to infinity, so there is an infinite amount of energy that has been stored here. Okay, because in a periodic signal it is a continuous signal, and if you are going to, what is the meaning of integration? Integration means addition. So if you are going to add each and every lobe here, you are going to get the infinite energy. So this point is very important, that if we have a periodic signal, then the energy is infinite. Let me write down for periodic signal, for periodic signal the energy is infinite. Okay, now we will solve few questions over this, then you get to understand more clearly how to find out the energy. But yes, you need to understand this one formula only, and that is more than enough. Now let's talk about the discrete signal. Now I am hoping that everybody knows what is discrete time signal. So let me just remind you clearly that discrete time signals are those signals in which the time axis are actually in a discrete form. What is the meaning of discrete form? For example, I have a signal xn. Like this, 1 2 3 4 5, like this. Okay, just for an example, this is an arrow sign. Arrow sign will say you that what is the magnitude at n equal to 0. The n equal to 0, the magnitude is 2. Now in right side we have the positive value of n, in left side we have a negative value of n. So if I want to find out what is x1, the x1 is actually equal to 3, which is because it is n equal to 0, so this will be n equal to 1. Now the point is, if I ask you what is x 1.5, the answer is not defined. The particular answer is not defined. Why? Because I told you the time axis has been in a discrete manner. Discrete manner means there has been divided into an integer form, 0 1 2 3 minus 1 minus 2. We don't know what will be the magnitude between two integers or between two discrete instant. That is the meaning of discrete time signal. For example, in a continuous time signal, if you talk about the last example, in a continuous time signal you can find out the energy at any instant, or I can say the particular magnitude at any instant, whether it is 2.25, whether it is 2.2225, है ना? But here we cannot find out the energy at every instant. We have to find out energy only at a discrete value or the integer value of n, right? Now in case of a discrete, now what happened, what is changes come when we talk about continuous to discrete? The integration change into a summation. The only difference is that you have to change the integration into a summation. So if I talk about energy of a discrete signal, it will be n is equal to minus infinity to infinity x n whole square. Okay, the same formula we have here. We have a magnitude of xn. So again, if a xn is a complex signal, it will give you magnitude, otherwise it will give you the simple square of a real number. For example, I need to find out energy of a above signal. I need to find out energy of this signal. So here you can see that arrow sign will tell you what is the position of n equal to 0. Though it is the signal is from n equal to minus 1 to n equal to 3. The signal is from n equal to minus 1 to the n equal to 3, right? So if the signal is from n equal to minus 1 to n equal to 3, I can also write down energy is equal to n equal to minus 1 to 3, where it comes out to be xn whole square, like this. I can write down like this, right? So if I open the summation, it become x minus 1 whole square plus, I will say it will be x0 whole square, then I will say it will be x1 whole square, sorry, plus 1, then I will say it will be x2 whole square, and finally I will say it become x3 whole square. So just we need to square the each and every magnitude of a discrete signal and add them. Simple concept. Finish. right? So this will be the energy of the given signal I have shown you here. So 1 plus 4 plus 9 plus 16 plus 25, so it comes out to be how much? 25 plus 35, 35, 39, 49, 55, right? You can check the calculation also. 55 units. Okay, 55 units. So here you can see, simple. The particular formula is very much simple. It's not that means you have to apply and solve a very large calculation. The formula is very much simple. Just you need to understand that what is a discrete time signal. Once you understand what is a discrete time signal, then you can solve the question very easily. Okay, now let's do few questions here. Let's suppose I have a rectangular signal. As you can see on your board, you have a rectangular signal. I need to find out energy of this signal. So let's go into a derivation. There are few particular signals for which you need to remember the for which you have to remember the formula of energy directly. Okay, one of that signal is the rectangular signal. Okay, why? Because these type of signal has been asked many times in your exam. So if you remember the formula directly, it will conserve your time, as well as if this is a part of one bigger question, then you can solve that question so much easier if you know what is the energy for in a first hand. So let's talk about, I need to find out energy here. So I know the formula of energy is minus infinity to infinity xt whole square dt. Now if you see this question very carefully, what is the signal here? The signal is from minus t by 2 to t by 2 and the magnitude is a. The signal is from minus t by 2 to t by 2 and the magnitude is a. So the integration limit will be changed to minus t by 2 t by 2 and the magnitude is a. So how can I write down this particular point? Let me write down integration from minus t by 2 to t by 2, and this is a whole square dt. Now let's do the integration. It comes out to be a square t from minus t by 2 to t by 2. So it comes out to be a square t. Okay, so this is the formula of energy for a rectangular signal, and I will advise you to remember this. I will show you some particular questions here where you can use this particular answer or the result directly. So we have E is equal to a square t, that is also written here. So this we need to remember for the rectangular signal. Simple enough. I hope you find out that the calculation of energy is very simple. So it's a very simple. Energy of a signal is a square t. Now let's see the next question. Now next is a triangular function. Again, it's going to be a easier one, but again you have to remember this. Okay, so let me draw the signal here. Let me change the pen and draw the signal. So okay, so if I talk about a rectangle signal, triangle, we are talking about triangle. So if I talk about a triangle signal, this is how much? Let me check. Minus t by 2 to t by 2, and it is a, and it is xt t. Okay, now how to find out energy? The simple formula here is going to be minus infinity to infinity xt whole square dt. No need to put the mode here because the signal here is a real signal, so no need to put a mode here. So if you solve this, if you observe this question very carefully, you can see this particular signal is from minus t by 2 to t by 2. This signal is from minus t by 2 to t by 2, right? Now observe again, this is actually a even signal because x minus t is equal to xt. For a even, this is an even signal. For even signal, I can write down, I can use the identity that 2 times of 0 say t by 2 x square t dt. We only need to integrate the one side and put the 2 in front of it. So this is the identity of a definite integral. If you don't remember, let me show you that if you have an even signal minus t, or I can say minus a to a fx dx. So for a even signal, it become 2 times of integration from 0 to a fx dx. This is for the even signal. What happen when you have a odd signal? Think about it. It becomes 0. The integration becomes 0. So this is a simple observation that we have find out, or we have used in 12th class also. Okay, simple application of integration here. So I can say 0 to t by 2 x square t dt. Now I need to find out the signal here. I need to find out a signal here also. So let me see what will be the signal here, xt. xt is going to be equal to, I will say, minus 2 a by t plus capital A. So this is going to be a signal xt, but from where to where? This is the signal xt from 0 to t by 2. Now many students can ask here, ki sir, how did you find out the equation of this line so easily or so fast? Beta, I use the concept of y is equal to mx plus c. Now what is c? C is the y intercept. So here y intercept is a. What is m? M is the slope. Now what is slope? Change in y divided by change in x. Now you can see clearly this is the change in y and this is the change in x. So change in y is a, change in x is t by 2, and because the particular line is decreasing, it means the slope must be negative. So that's why the slope here is minus 2a divided by t multiplied by t. Okay, so this particular equation we find out so much easily and in a less amount of time if you understand this particular equation of line, which is y equal to mx plus c. Okay, understood? Now let's find out energy. Let's put this value here. So I will say energy is equal to 2 times of t, 0 say t by 2 xt. Xt is minus 2a by t multiplied by t plus a whole square. T plus a whole square dt. I guess I'm correct. So if I do the integration here, so it become minus 2a by t multiplied by t plus a whole cube divided by 3 multiplied by minus t by 2a. From where to where? We need to write down from 0 to t by 2. From 0 to t by 2. So first of all, I can take minus t by 2a outside. If I take minus ta by 2a outside, it become 1 upon 3 times of a. Fine. If I put t by 2 here, t by 2, it becomes 0. If I put 0 here, it become minus a cube. If I put 0 here, it become minus a cube. If I'm not wrong, let me check the calculation. So there is also t outside. Now I kept the t by 2a outside. Okay, fine. So okay, after solving this, a and a cancel out. It become a square t by 3. So the energy of this triangular function is how much? A square t by 3. So here you can check. It is a square t by 3. Let me show you. It is correct. It is a square t by 3. Simple. So again, this formula you need to remember. This formula, guys, you need to remember. That's why I showed you the derivation here. Sometime it will happen in your examination that you forget the formula. So don't worry about it, because once you know that particular derivation, you can easily find out formula if you forget it. But I will strongly advise ki some basic formulas you should remember, so that the question becomes so much simpler to use and consume less amount of time. Okay, and these kinds of shortcut tricks, these kind of questions we are also going to solve in our paid batches, where you can have the ultimate knowledge, you can get the ultimate knowledge about all the subjects I will taught there. Okay, fine. Moving further. Now for this, the derivation of this particular signal you will do in a homework. But let me tell you what this signal is. This, yes, you need to remember this formula, but you need to understand what is this signal. So if you see very carefully, this is the half triangle. See very carefully. This is the half triangle. Why I'm saying this is a half triangle? Because if you see the earlier figure, if you see the earlier question, this was the complete triangle and we showed minus t by 2. So if I remove this dotted line here, it becomes the half triangle. That's why energy become half. In the earlier case, energy was a square t by 3. But right now, the energy here is a square t by 6. So in this manner, you can remember the formula here. Okay. So finally, let me write down which formulas you need to remember. Let me write down finally. And these three are enough. These three are enough. So let me write down finally, bachcho. First of all, energy of any signal. Energy of any signal is equal to minus infinity to infinity x t whole square dt. Right? Now for rectangular signal, if I have a rectangular signal of magnitude a and the duration t, then the formula you need to remember, a square multiplied by the duration. Now if you have a complete triangle signal, if you have a complete triangle signal like this, which is minus t by 2 to t by 2 and the magnitude is a, again this is a complete duration. So the formula is a square multiply by complete duration divided by 3. And if you have a half triangle, or I can say specifically the right angle triangle, if you have a half triangle, or I will say the half angle triangle like this, this is A. Let's suppose this is a complete duration, this is a complete duration. So the formula of energy here will be A square, the duration it is, divided by 6. Okay. So these three formulas you need to remember. We are going to use these three formulas directly in our question one by one. Okay, but before that, there are also the few other signals that we need to understand. First of all, you can see the bounded exponential signal. Although I have mentioned the formula here, but no need to remember this. Okay, so as you can see, this is a particular signal in which the exponential signal, which is a continuously a decaying signal. So can we derive the formula of energy here also? So let me draw it. So we have D, a signal xt, and suppose the initially the magnitude is A, and then it is decreasing like this. So I'm saying, what is xt? Let me check one point. I will say the xt is equal to A e raised to power minus at. Okay, minus at ut. Now for the signals, I need to put ut and u minus t there to show or to represent that the signal is starting from one specific point. For example, here the signal is starting from origin, so you have to mention ut. But these kind of ut we don't mention in network theory, or you can say a control system, very much. Okay, but this is a general practice to represent it. Now let's talk about energy. If I talk about energy, we have only one formula, and that is more than enough. I'm telling you again and again, because you will see many videos of many faculties, you will see many other books also, they will show you the multiple formulas of energy, but that is not at all required. Just you need to remember this formula. So here we can see, because we have a signal minus infinity to infinity, if I have a signal A e raised to power minus at ut whole square, because this is going to be a real signal only, so we are only have a magnitude here. Now see very carefully, because of ut the interval will change from 0 to infinity, because before 0 there is no signal, so the particular integration limit will change from 0 to infinity. Obviously, I hope you understand this particular phenomena, that the particular limit will change from 0 to infinity, and if I square inside of the bracket, it become a square e raised to power minus 2at dt like this. So I will take a square common, e raised to power minus 2at divided by minus 2a, and the limit is from 0 to infinity. So if I put a limit here, it become a square divided by minus 2a, it will be e raised to power minus infinity minus e raised to power minus 0. Now everybody knows e raised to power minus infinity is 0, but it is equal to 1, so it comes out to be a square by 2a. So I will say the energy of an exponential signal e raised to power minus at ut is how much? It is equal to a square by 2a. This is the formula of energy. But yes, no need to remember it. You can solve it easily in your examination. You can solve it easily in your question, okay, or in your exam. Now next, a very important feature, and on this particular topic many time question has been asked in an examination, the impact of shifting and scaling on an energy. So in the first case, I am going to take the time shifting phenomena. Let's suppose for xt, for any signal xt, the energy given is E. For xt, the energy given is equal to E. Then the question is, what will be the energy of xt plus minus t naught? The question is, what will be the energy of xt plus minus t naught? Simple question, as you can see, है ना? See, I can also show you the derivation of this particular property of time shifting, but in the end you have to remember the fact only, or remember the effect only. What is the effect or the impact of a time shifting? Okay, so let me write down the impact only. I guess the derivations which are not important that you can skip easily. Okay, no need to worry about each and every derivation, because what happened, let me tell you. Right now your goal is to clear the exam. Simply understand this point. Your goal is to clear the exam. If you want knowledge, you had enough time to get knowledge in your college days. Right now your goal is to get and clear the examination. Okay, once you clear examination, then if you have a itch in your mind ki yes, I need to understand why that happened, then go towards that particular thing. And I'm totally saying this for the unnecessary derivations that most of the students indulge with. Right now during a preparation time, don't indulge with the unnecessary derivation. Okay, the derivation which are very important, which have to come in your examination, without which you cannot understand the question, then obviously you can go to the derivation, and I will definitely force on that. But the derivations which are no way going to help in examination, no need to do it, just skip it. Okay, so what is the time shifting property here? So the point is, energy does not impacted. Energy does not impacted. A very simple phenomenon. Okay, you want derivation? I will show you the derivation. So let me see the energy formula is minus infinity to infinity xt plus minus t naught, xt plus minus t naught whole square dt. I need to find out this energy. Let's suppose this is equal to energy of a signal y. Okay, now let's suppose let t plus minus t naught is equal to tau. So I can say dt is equal to d tau, and there is no change in a limit. So it will be energy of y is equal to how much? Minus infinity to infinity x tau whole square d tau. Now simple, what I can do, I can replace the tau by t. This is the simple application of a definite integral. You can replace any replace any variable in integration. So if I replace this variable in integration, it is equal to e raised to power x, which is the original energy. Let's suppose the original energy here is ex, which is equal to the original energy. So the main point is, if you shift the signal, there is no impact on the energy. Time shifting we are talking about, there is no impact on energy. Okay, understood? Now next signal operation, let's suppose amplitude scaling. Okay, amplitude scaling, let me show you. The next is amplitude scaling. Very easy. So if you talk about the amplitude scaling, okay, now what we can do here, understand here, let's suppose I have a signal xt which has energy E. If we have a signal xt energy E, then I have a signal yt which is equal to E times of xt, and the question is what will be the energy here. So let's suppose I'm going to find out the energy of a signal y. So I will say it is minus infinity to infinity a square x square t dt. Simple, I have put yt equal to axt. If I take a square common, it comes out to be minus infinity to infinity x square t dt. Now this is equal to energy of a signal x. So simply what happened in case of amplitude scaling, the particular the amount by which a signal has been scaled, that will become the square times in case of energy. Okay, simple. For example, simple example, let me take an example here. If a signal xt has an energy of 4, then I have a signal yt of 2 by 3 xt. Then what is the energy of yt? Simple, square this particular term, which is 4 by 9 multiplied by 4, and you got the answer. Simple. In amplitude scaling, the energy become a square times of the initial energy. Okay, last operation we will see the particular time scaling. Next operation is a time scaling operation. Now let's see what is the time scaling operation. If a signal xt has energy ex, then what will happen to a signal yt which is equal to xat? What will be the energy here? Let me write down simple result. The energy ey is equal to 1 upon mod a ex, and finally you need to remember these results. Okay, the derivation I will give you for a homework. Do the derivation for it and check whether you are getting the same result or not. Okay, so in general I will say that if I have a signal like this, A x at plus b. So here you can see you have a amplitude scaling also, you have a time shifting also, and time scaling also. So what will be the energy of this signal? So first of all, the energy of original signal is Ex. Now because of amplitude scaling it become A square, and because of time scaling it will be divided by the magnitude of A, and there is no impact because of the shifting, because of the time shifting. Because of time shifting there will be no impact. Understood? So this is the final answer you need to remember, or you need to understand the statements or a result here. For example, we need to find out the question is wrong. The question is wrong. Let me correct the question. Just 1 minute. Just 1 minute. Let me correct the question in original file. If the energy of signal signal xt equal to 100 units, then energy of this signal we need to find out the energy of this signal. Okay, so I will advise everybody to pause the video and then solve it. Okay, so I hope you have already solved it. Let's start the solution. So we have given the energy of signal xt is equal to 100. Now here you can see I can represent this signal like this also, x 3t by 4 minus 7. X 3t by 4 minus 7, I can also represent this signal like this. Now if I can represent the signal like this, what will happen to the energy of this signal? Let's suppose it is y. So there is no amplitude scale, 7 by 4, there is no amplitude scaling here, so it will be Ex divided by the amplitude is time scaling, which is 3 by 4 sorry, 1 by 8, 3 by 4. So 4 by 3 multiplied by 100, it becomes 400 by 3 joules. Simple. Or units, they didn't mention the unit, so 400 by 3 units. Simple. Okay, understand? In this way you can use this particular formula. Now let me find out energy of one signal also. Let's suppose I have a step signal. Okay, the question is find energy of AUT. For example, I need to find out energy of this signal. Now solution. First of all, what is AUT? It is a step signal. We already know it will be equal to A for time greater than equal to 0. It will be 0 for time less than 0. So I can find out energy. The simple formula, energy is minus infinity to infinity x square t dt. No need to use the mode here because we have a particularly, I will say, we have a real signal. So the integration will change from 0 to t, right? And the magnitude here is a square dt. So I will say 1 point here, I will take a square outside, it will be 0 to t dt. Now what is the 0 to infinity? Why I am taking t? 0 to infinity, my fault guys. 0 to infinity. So a square, I will say t from 0 to infinity, the answer comes out to be infinite. It means the energy of this signal is infinite. Why this happen? I will tell you the summarized result after few minutes. Just wait for few minutes, then I will tell you the summarized result. Okay, why this happened? The energy of this is actually comes out to be only infinite. The energy of this signal comes out to be infinite. Just wait for few minutes and I will summarize the complete result. Okay, if you got any doubt, you can post your doubt in a comment section also. Now the question is find the energy of this signal. Okay, let's discuss find the energy of this signal. Okay, now first of all, before starting energy, can you tell me what is the mod xt here? I hope everybody knows the mode of e raised to power j theta is equal to 1. Why? You know e j theta is how much? It is equal to cos theta plus j sin theta. It is cos theta plus j sin theta. If you take a magnitude here, it will be under root of cos square theta plus sin square theta, and the magnitude is 1 here. So e raised to power j tan t, the magnitude is actually 1 here. Now if I'm going to find out energy, again I'm writing the formula minus infinity to infinity x t whole square dt. Now here we got minus infinity to infinity 1, and the answer comes out to be again infinite. The answer comes out to be again infinite. Okay, now why this happened? Why I'm getting the infinite answer in the last two cases? If you observe this case or if you observe the last case, why I'm getting an infinite answer? So let me summarize all the points here. So simply I'm going to tell you the important points. Simply I'm going to tell you the important points. So understood very carefully. What are the important points here? Let me write down. The first point. Achha, tell me guys, do you want that typed do you want on PPT that typed notes, or you want whatever I am writing it right now? Because I have two particular points. Either I can bring you the all written notes or all written points, and I just need to dictate that particular point or read that particular lines there, or I can write the particular lines while I'm explaining that. I'm more comfortable in the second case, but whatever you decide, you can tell me in a comment section. Your particular views are highly appreciated. Now again, you can join my Telegram channel. Also download my app. The link is given in the description. So let's talk about the first important point. Energy of a periodic finite duration signal, a periodic finite duration signal is between 0 to infinity. This I'm talking about a periodic finite duration signal. For example, we have seen two type of signal. One is rectangle and one is triangle signal. In both of these signals, these are aperiodic. Both of these, let me change the color of a pen, I guess. Both of these signals are aperiodic. Also, these are the finite duration signal. Now second, energy of a periodic infinite duration signal that approaches to zero at t tends to infinity is finite. Now again, understand this question very carefully. Now I'm telling you energy of a periodic infinite duration signal. So what is this signal? For example, the exponential decay signal. Now exponential decay signal is aperiodic, but the point is it tends to 0 when the time tends to infinite. You can see this signal. The signal, if I say the limit t tends to infinity xt is actually equal to 0. So the limit t tends to infinity, the signal xt is approached to 0. So for this, the energy is actually finite, and we calculated it. It is 1/2a, right? Third point. Wait a sec. Let me add one page. Now third point. Energy of a periodic infinite duration signal which is not zero as t tends to infinity is infinite. For example, the step signal. We just calculated the energy of a step signal. If you see, the step signal is aperiodic, first one, infinite duration, but the signal is not tends to 0 as t tends to infinite. So it means energy in this case is infinite. Also, you can check one more signal. For example, ramp signal. This is a ramp signal. Here again you can see this is a aperiodic infinite duration signal, and the condition is that as t tends to infinite, energy will be infinite because the magnitude at t tends to infinite is not 0. Last point, energy of energy of periodic signal is infinite. The simple point is, wait a sec. The simple point here will be, let me erase this. The energy of periodic signal is infinite. Right? Understand? Simple concept, na? So these 4 points you need to understand, and you can identify many different type of signals. I will discuss that also. So first of all, if you have a aperiodic finite duration signal, the energy is finite. When you have a aperiodic infinite duration signal, but the magnitude tends to 0 at t tends to infinite, then you have a finite energy. If you have a aperiodic signal of infinite duration where signal is not tending to 0 as t tends to infinite, then you have a infinite energy. And also in case of a periodic signal, you have a infinite energy. So these 4 cases, or these 4 points you need to remember. Also the impact of shifting and scaling. Once you remember these particular formulas or these particular results, you can solve any question of energy signals easily, or energy of a signal. Now the last topic in this particular scenario is the energy for a combination of a signal. So let's suppose I have a signal xt is equal to x1t plus x2t. Okay, now if I want to find out energy of xt, so what can I do? I can use this formula, minus infinity to infinity x1t whole square, or I will say like this, not like this. We will use the mode, because a signal can also be complex now. A signal can also be a complex signal. So I will use mode. So x1t whole square, or thing. Again, I have done a silly mistake here. Wait a sec. There is problem with my pen. Okay. So we need to find out energy of xt. So we can also write down in this manner, energy of xt is equal to x1t plus x2t whole square dt. I can write down this manner. Okay. So it will be minus infinity to infinity x1t whole square dt plus minus infinity to infinity x2t whole square dt, also plus minus infinity to infinity x1t x2 conjugate of t. Okay, this is the formula to open the mode of two signals x1t x2t, plus minus infinity to infinity x1 mod of t x2t dt. Okay, so this is the complete formula of energy. I can also write down energy of xt is equal to ex1 plus ex1 plus ex2 plus minus infinity to infinity x1t x2 conjugate t dt plus minus infinity to infinity x1 conjugate t x2 t dt. Now if you have an orthogonal signal, it means if x1t and x2t are orthogonal signal. Now what is the meaning of orthogonal signals? The meaning is, if you only on this level, I'm telling you, on this level just you need to remember, orthogonal signal means two signals in which are not overlapping with each other. So in case of an orthogonal signal, what happen? Minus infinity to infinity x1t x2 conjugate t dt is equal to 0. Also x2t x1 conjugate t equal to 0. So if I have a orthogonal signal, then this whole term becomes 0. So I will say, what is the energy? Energy is equal to ex1 plus ex2. Now this is very important result. This is very important result. Why? This result will tell you, if you have a signal in which multiple signals are in addition or in subtraction, then what you need to do, you need to divide a signal into a multiple forms, into multiple signals, and find out energy of an individual signal. Once you find out energy of an individual signal, then you can easily find out energy of a complete signal. Okay, now let's see here. For example, see here, calculate the energy of this signal. The question is calculate the energy of this signal. Now this signal I can divide into three parts. This signal I can divide it into a three parts. This is x1t minus 3 1. This is x2t 0 2 2 3. Okay, this is x2t, right? And finally this is 2 to 4, and this is 1. This is x3t. So I can divide the complete signal in three particular signals. So I can say what is the signal of complete signal. It will be the energy of signal 1, energy of a signal 2 plus energy of a signal 3, and all these signals are actually orthogonal. All these signals are actually orthogonal, so there is no need to worry about the integration of their conjugate part. So here you can see what is the signal of x1t. It is a rectangular signal. The rectangular signal is magnitude whole square multiplied by the duration. No need to use the sign, use the duration. Okay, what is x2t? Again a rectangle signal, so I will say 3 ka whole square multiplied by duration. Now triangle, what was this? Is a if you say this is the right triangle, this is a right triangle. The formula was a square multiplied by duration by 6. So a square matlab 1. So 1 whole square duration is 2 divided by 6. Divide by 6. So it comes out to be 3. 9 2 ja 18 plus 1 by 3. So it comes out to be 3 1 ja 3, 2 2 ja 63 plus 1 by 3. Simple, 64 by 3 units. So this is the energy of this signal. Okay, simple. If you have solved this question using the formula, if you solve this question using the formula, it will consume much amount of time, but we have find out the formula so much easily without any without any much calculations. Okay, now the same case here, I need to find out energy of this signal. Simple. If I say this is x1, if I say this is x2, then I can find out energy easily. But one point you need to understand again, this is the right triangle. One thing you need to understand again, that it is a right triangle. So for right triangle, what is the energy? Energy is a square multiplied by duration by 6. Okay, so understood this. Now what will be the energy of this signal ex1? A square, 4 square, duration is also 4, divide by 6. So it comes out to be 16 4 ja 64 by 6. And what is ex2? Amplitude ka whole square multiplied by duration divide by 2. It comes out to be 4. Now final energy will be how much? 64 by 6 plus 4. I will say let's convert into decimal. So 6 10 is 60, 40, 6 36 plus 4. So 14.6 units. 14.6 units. If you find any calculation mistake in a comment section, you can tell me. So it will be a 14.6 units. Simple question, simple answer, and you can see without going into a much calculation, you can find out the answer easily. Now next, this you need to do it by yourself. This is your homework. This is your homework, and I'm hoping all the students who are watching this video kindly give the answer in a comment section. If you got the right answer, I will provide the like button. So kindly provide the answer in a comment section. It will also you can also check by yourself whether you understand the topic or not. The last 15 minutes you have invested with me, whether that will be a fruitful for you or not. So that's why you have to solve this question. Also I will give you one more question. So I'm giving you two questions here. I'm giving you two questions here, and this question is more important. This question is more important. So let me give you this question. I have a signal xt, this is t, and here I will say this is 1, this is 2, this is minus 2 to t. The formula is find energy of this signal. Find energy of this signal. So these two are the actually homework for you. So try to solve this question, give me the answer. Once you provide the answer, I will provide the like button, so that everybody will get to know whether your answer is correct or not. Okay, for the solution, again you can join my Telegram channel. I will also upload the solution there for both of these questions. Okay, Now I can see, now we will see, see one point. Since the video is about to be 1 hour, and for the longer videos I don't think people will sit. So what I'm going to do, this is going to be a first part of energy signals, energy and power signals. The second part will be upload tomorrow. In this part, remember what we have learned. We have learned how to find out the energy of a signal. Okay, in the next part I will discuss how to find out the power of a signal. Once we will discuss these things, then I can identify which signal is energy signal and which one is a power signal. So we will end our video here, but don't forget to download my app and enroll in a paid course if you are preparing for your upcoming gate examination. So bye guys, take care.